Swifter, it's Professor Gallagher, and it's time to pick up those pods, brush off those beats, and come on, feel the noise, because in this lesson, we're going to learn how to add sound to your app. And along the way, we're going to learn about importing modules to expand what Swift can do, we'll work with sound files, and we'll get our first taste of error handling with both guard let and do try catch. Crank up that volume, it's time for big learning. And friends, a quick request. If you've been enjoying this, do the old man a solid, like and subscribe, and tell your friends. It'll help me reach more people, and it keeps me motivated to keep the goodness coming. I really appreciate that kindness. All I want to do is reach more people. Nobody makes money on YouTube. And if you're new here, welcome. You might want to check out the playlist with over 100 order lessons from the award-winning Zero to Full Stack course that I teach at Boston College. Now let's first do some quick cleanup from the last lesson. I have a bunch of natural language comments in here that helped us think about our code, but we don't need this anymore, so I'll highlight and delete this. And I mentioned that you could convert your while true loop used to show non-repeating random images to a repeat while loop. So let's do that quickly. I'll highlight and cut out the while portion below where we declare our image number. I'll replace this with the keyword repeat, and then I'll paste the while condition I just cut out at the end of the loop closure's closing curly. And for efficiency, why don't we get rid of the initialization of a random value when we declare our image number? We don't need that because we get a random value inside of our repeat loop. We can just explicitly declare this with :int. And we're done. Works like magic. And you know what? There's one minor edit, but I think it's good practice. If you can, you should avoid having literal values buried in your code like this. The 9 that we have here is because we have images in our asset catalog labeled image 0 through image 9. But if we wanted to add or subtract images, we'd have to hunt for this number in our code, looking every place where this number exists. The first time you look at this line, it might not be entirely clear that this refers to the number of images. It'd be far better if we declared this value as a constant and then use that constant whenever we need this literal value. And we can put constants like this at the top of our code where they're easier to find. So at the top of the code, we'll create a constant with let. Why don't we call this number of images lower camel case? We'll set this equal to 9 because we have images labeled image 0 through image 9. Oops, bad me. Because of zero indexing, the number of images is actually 10. So now if we need to change that value because we've added or subtracted images, we only do it in one place at the top of our code. And now if we go back down to that range, we can replace the literal 9. By the way, you'll often hear programmers refer to literal values buried in code like this as magic numbers or magic strings, and that's usually bad. They're not really magic. It's sort of a joke. They appear in your code without any explicit meaning or purpose. They seem to have some kind of magical impact. So if we replace this with number of images, first we see that the constant shows up in code completion, one big advantage, and it has a clear name that describes its purpose, another big advantage. We'll just subtract 1 from this value because of zero indexing, and that's good coding practice, Swifter. We'll learn more best practice techniques like this as we continue with our course. Well, app developer, when we left off in our previous lesson, our You Are Awesome app was displaying random images and random messages. And by the time we're done with this lesson, your app will be playing random sounds too. Now, in order to play sounds in your app, you're going to need sound files. Now, the code we're going to write will play all standard sound files, MP3s, waves, and just about any format that Apple uses for downloads from iTunes or music, as long as there's no DRM or digital rights management locking the file. Now, for this teaching example, I put together 6 cheering sounds that I really like. You're welcome to use those for your learning as you follow along, and you can find them in the Google Drive at bit.ly/prof-g-swiftui-files, all lowercase. Just go inside the folder for the You Are Awesome app and right-click to download the sounds folder. Now, there are lots of ways to prep your own files, including using the free QuickTime player that's on your Mac. To make a recording in QuickTime, just go to the File menu, select New Audio Recording, press the Record button, and anything from your mic will make it to the sound file. Dang, you Swifty! Then save that and you're ready to go. And there are also lots of free sound files online. Just remember, you always want to make sure that you have the right to use any sounds in your app, otherwise your app will be rejected from the App Store and you'll be in violation of copyright law. Now that said, for educational purposes, you can use pretty much any file on your own as long as you're working with your own app installed on your own device. Now this tutorial assumes you've got 6 sound files named Sound 0 through Sound 5, all one word, all lowercase. Feel free to add more or fewer sounds, and it's going to be pretty obvious where you need to modify our code to account for a different number of sounds. But once you've got those, you can add them to your assets catalog just like you added images. Just click on Assets in the Project Navigator and drag them over into the pane that holds your files. I like to put them in their own sounds folder so that they're nicely organized and separated from the other assets too. To do that, head down to the plus button in the lower left-hand corner of the column, click it and select Folder from Selection. Give the folder a name. I'm going to call this Sounds. And then I'm going to do the same thing for my images, put them in a folder called Images. You don't even need to click the plus button. You can right-click to pull up the Quick Action menu and select New Folder from Selection. This is only for organizational purposes. It doesn't impact your code at all. So here are the steps for playing sounds. Add the sounds to our assets catalog, then in our code, import AVFAudio, create an audio player object, read in the sound that we want to play from the assets catalog, and then play the data through the audio player. Now we've already added sounds in the asset catalog, so let's head over to our code. And in the content view, notice the import statement up top. It says import SwiftUI. Well, we get this by default when we're building SwiftUI apps, and this is the way Apple adds all of the Apple extra SwiftUI stuff on top of the basic Swift language. So just to be clear, Swift is the generic programming language. When we see loops, arrays, basic data types like strings, ints, and doubles, that's all part of Swift. So this is the open source language that Apple helps create, but that you can run on everything from high-end servers to tiny microcontrollers that cost less than $7. Now, SwiftUI is an Apple set of frameworks and tools for building apps for Apple platforms, iOS, Mac, iPad, Watch, tvOS, Vision Pro. It uses Swift, but it's in addition to the basic Swift stuff. So SwiftUI is the proprietary Apple stuff, and it's not open source. So when we deal with views like buttons, text, colors, stacks, when we work with the asset catalog and things that are specific to Apple products, in this course we're going beyond Swift and mostly using SwiftUI. Now as an Apple developer, know that Apple doesn't include all of the features in its platforms by default. So with this import SwiftUI statement, we've gotten all the commands and data structures we've used so far, but we don't get everything. If Apple included everything in all apps, your apps would be bloated, files would be larger than needed, and building apps would be slower. So for less frequently used features, we tell our program to import the methods and data structures as we need them. And to do that, we use the import statement. Now, audio is one of those less used features. It's not included with SwiftUI because most apps don't use audio. But including the extra stuff that we need to begin programming for sound is really easy. All we do is say import AVFAudio. That's one word. AVF and A are capitalized. You should find that in code completion. AVFAudio is Apple's framework for working with sound. Do that, and we're ready to work with sound. Next, we're going to create an audio player. Now, an audio player is just a software object that handles playing sounds. And if it helps, you can think of this sort of as the audio equivalent of a button or a text view. Now, we want the audio player to linger around even as the user interface is redrawn. So we'll create this as a state variable with @state, private var, and we'll call this audio player, lower camel case, which is a good name for an audio player. And we need to use the syntax that we learned in the prior video for declaring but not initializing a variable. So we'll say :AVAudioPlayer. Select it from code completion so you get the capitalization correct. And code completion also says it's an object that plays audio data from a file or buffer, just what we want. But we actually need data to initialize this, and we don't have that data yet. The data is in our sound files, and we're going to access that further down in our app. So what we're going to do is just add an exclamation point after the audio player, no space. Now when you do this, when you declare a variable, it's called implicitly unwrapping an optional. Now what this means essentially is, right now, if you try to use audio player, it's not there. It's what's called nil, an absence of any data. But as a programmer, we're taking responsibility to tell our program it's okay to assume that something will be in here when we finally do access audio player later on in our code. Now we'll actually see later on that the first time we use audio player, we initialize it with AVAudioPlayer, and we'll put data from our sound file inside of it. Now this business about implicitly unwrapping optionals might not be very clear because we haven't done much work in Swift with nil values. We're going to cover how Swift deals with nils, optionals, unwrapping in a future video. But for now, it's really okay to treat these two lines here as something that you've got to enter whenever you want to work with audio in your apps. Now here's an important aside. If we didn't include this first statement, import AVFAudio, then the data structure that we use down here, AVAudioPlayer, wouldn't be available. It wouldn't show up in code completion. If I tried to type this anyway, Xcode would give me an error saying, cannot find AVAudioPlayer in scope. That's like referring to a variable that we haven't defined yet. Now in earlier versions of Xcode, if you got this error, you had to remember which module you needed to import. But modern Xcode is better than it's ever been, and you get this little fix button in here. If you click that, Xcode will add the import statement for you. Thank you, Xcode. Now let's add the code to read in the audio file from the asset catalog. And since we want the audio to play when the button is pressed, we're going to add that to the closure that contains the button action. So we'll make space just after the image code and before the button action's closing curly. And now here's how we read a file in from the asset catalog. First, we want to make sure that we get a valid file. It could happen that we try to access a file using the incorrect name, or we forget to add the file to our assets catalog, or very rarely that the file's corrupt. So we need to check to make sure that we can read in the file. And to do that, we're going to use a guard let statement. Now, guard acts as a traffic cop. If you complete the test that's in the guard statement, then it will let you continue after the curly. If not, then you're returned and you won't get to complete the closure that the guard let is in. So what's this let statement that we need to complete? Well, we know what let does. It creates a constant. So this will be a constant named sound file. And to create this constant, we use the NSDataAsset command. Now, code completion for NSDataAsset will say it initializes and returns an object with a reference to the named data asset in the asset catalog. Now, what that means is it'll take the data from the file with the name that we pass into NSDataAsset. So this is going to be a string with the file name. We're going to pass that in using this variable sound name. If it can get that data, cool, it's going to create the constant. Now, why do we need the guard? Again, this might not work. If we pass in the name of a file that doesn't exist, if the file's corrupt, if any of that happens, we can't create the constant. So if we can't create it, guard won't let us through because the condition that it's guarding to approve isn't met. Now, if it can't get through, meaning it can't create the constant sound file, then we execute these curlies after else. Now, this has to have a statement that stops the execution of the current closure. So for us, that means it's going to exit the button action. We're not going to execute any more code inside the button action curlies. And the statement we use to do this is return. So in this case, return is going to say, go home, no more button action code for you. Now, technically, you don't need this print statement before the return statement, but what it's doing is it's printing out a message to the console that says, hey, an error occurred, and it prints the string inside the variable sound name so I can double check the spelling. And pro tip, adding emojis to print error statements like this helps you identify them quickly in the console that might have lots of other output in it. Now, what happens if we do create that sound file constant? We have no problems. The sound file constant is created, guard lets us pass, so we passed its test, and the constant sound file lives for the rest of the closure, which means for the rest of the button action. By the way, guard let is a Swift statement, and NSDataAsset is an Apple-specific command since it uses the asset catalog, something that's not part of non-Apple products. Now, before we add the code that I just showed you, I'm going to create a constant sound name and set this equal to the sound that we want to play so we can test our code. So enter let sound name, lower camel case, equals, and the string sound0, all lowercase, no spaces. So this will let us play that first file, the sound0 file. Now, this is where we write the code we just saw. Guard let sound file equals NSDataAsset. Choose the option where you pass in a name. Note the code completion description. Initialize and returns an object with a reference to the named data asset in our asset catalog. So select this with return. So we're going to pass in the name of the file in our asset catalog, which is sound name, which we set to the string sound0 in the line above. Then on the same line, we write else, open and close curlies. In between the curlies, we put return. So if we fail to create the constant with the NSDataAsset data, then guard won't let us pass and we hit return. We can't do anything else below the current closure. The guard bumps us out of the button action code. Now, we don't need a print statement above return, but this can be helpful because if we did hit the error, I'd like to see this in the console. So above return, I'll enter print, and then in quotes, could not read file name string interp. And in the string interp, I'm going to pass in sound name, that variable that contains our file name. And to type an emoji in front, I'd mention this is a good idea. You can press Control, Command, Spacebar, those three characters. That brings up this emojis and special character box, and you can scroll through the emoji, but there's also a search box. So I like to use angry emoji for my error messages. So if you just type angry here, these will show up, and I'll click this first guy, and it's entered into my print statement. I'll add a space after it. Guard statement done, and this is the code we need to make sure that we can read in sound file data from a file in our asset catalog. First, we need to initialize the AVAudioPlayer and play the data using the player. Now, we're going to use something that we haven't encountered before. Some Swift commands will do what's called throwing an error if they don't work, and they'll actually send back an error that can be printed out and that'll tell us why the command failed. Now, you can tell if a command throws an error because it says so in code completion. So we need to initialize or create an AVAudioPlayer. Remember, we created a variable called AudioPlayer that could hold an AVAudioPlayer, so we declared it, but we haven't initialized it. We haven't put any data inside it. Well, now we'll initialize this guy. So we're going to create an object called AVAudioPlayer. That's a special type, and to create it, we just write its name, AVAudioPlayer, followed by parentheses. There are a few ways to create it, but the one that we want is where we pass in data. We're going to pass in the data from the file that we just read in, and we do that by saying sound file, the name of the file we just read in, .data. So sound file has more stuff than just data. It might include information on the file type, for example, but we just want the data part of that file. So to get at that, we just say sound file.data, And now because this throws an error, we put it in a set of statements with 3 keywords: do, try, and catch. So do has curly braces around it. And inside, this is where we put the command that throws an error. Now we're going to preface the command that throws the error, AVAudioPlayer, with the keyword try. And what we're going to do if we create the AVAudioPlayer, so before the try, we're going to say AudioPlayer equals try AVAudioPlayer, passing in the data soundfile.data. And if this works, in the next line, we just execute the AudioPlayer's play method. That's going to play the data that we just read in. But if it throws the error, try fails, we immediately jump down to this catch clause in here. This is referred to in Swift as catching the error. In here, we do whatever we want to do to handle the error. And what I'll do is I'll just print out another error message. Now, what's interesting is when you throw an error, you actually get a value called error back. And you could print out error.localizeDescription, and that'll describe the problem that just occurred. So this looks really complex at first blush, but essentially we're just saying, hey, I'm going to try this. If it can work, that's great. I'm going to keep going. But if I can't, it's going to throw the error. So we're going to catch the error, and this is what I'm going to do. So now let's code this up. And I'll code the statements out of order to remind you what we're doing. So we want to set AudioPlayer equal to AVAudioPlayer passing in data. And look at the code completion. So to initialize or create an AV player this way, it might throw an error. See throws in here? So we'd mention that this means do, try, catch. So I'm going to press return to accept this, and first I'm going to pass in the value that has my data, which is soundfile.data. Remember, we want to get the data part of the sound file we just read in. And then above this, I'm going to write my 3 keywords: do, curlies, try in those first curlies, and then catch in curlies below this. And then I'll cut out the audio player initialization and paste it in where the try is, but I'm going to add try just after the equal sign. And if this works and we initialize the audio player, then after trying this, then we take our configured audio player and call the .play method. Code completion says this plays audio asynchronously. That's the standard sound playing method, so press return to accept that. And if the try doesn't work, and all I'll do there is print an error. So I'm going to copy the first part of this print statement here that has the angry emoji and paste it into my catch area. And watch this. If I write error, string interp, then go back to try to fill in the string interp, I don't get code completion. Now, code completion doesn't show up until after I've enclosed the string interp inside of double quotes. So pro tip, always close your double quotes before you go back to try to type between the parentheses and string interp. Otherwise, you won't get code completion. So now that I've closed my double quotes, if I type error, code completion suggests that lowercase, press return to accept it, then .localize description, and you see what code completion says about this. It retrieves the localized description for this error, so that's great. This will print out the error that occurred. And remember, that error is passed in automatically if this statement up here throws the error. And I'll finish the string by writing that the error was from creating audio player. Get ready for some cheering. Well, all right, we got our cheers with one sound, sound 0. So your challenge is going to be write code to play a non-repeating random sound from sound 0 through sound 5. Now your code to do this should be almost identical to the code you've already written to show the random image. Just when you're done, you should have a random sound in the variable sound name, and instead of creating image name, which has the string image in it, you're going to create sound name that has the string sound in it. So you'll get rid of the line here that creates the constant sound name and sets it to sound 0. But then when sound name is set up to that random value, you should be able to take your sound name and run it through the code that you just wrote. So modify your app's code so that you'll play random non-repeating sounds. And again, the hint, the code will be very similar to what you wrote to generate a new image name to use in the image view. Only here what you're doing is you're generating a new sound name, which should be a value from sound 0 through sound 5. And then once you have that new sound name value, you can pass it through the guard statement onward. That should all work just as is. So pause. I know you can do it, Swifter. And when you're ready, resume and we'll compare answers. So this code is super similar to code you've already written, but you're creating a sound name instead of an image name, and your string will have the string sound in it instead of the string image. So just below this, we'll declare a sound number variable, just as I did with my image number up here. That's var sound number :int. And I'll add a repeat while loop with repeat and curlies, and in the curlies I'll write sound number equals int.randomin 0.5 since I have 6 sounds numbered 0 through 5. But that 5 literal is kind of a magic number, so let's go up top and create a constant for this. Oh yeah, and while we're here, we're going to need a state variable to keep track of the last sound played, just like we did with our last message and last number. So we'll add @state private var last sound number, setting this equal to -1. And then down here, with our number of images constant, why don't we add let, and we'll call this number of sounds, set this equal to 6, because there are sounds labeled sound 0 through sound 5, and then down in our button action, we can end our range not with 5, but with number of sounds minus 1. Then the while condition at the close of the curlies is going to be while sound number equals last sound number, and I'll set last sound number equal to sound number, and I'll set sound name equal to the string sound, but a string interp inside the closing double quote, and I'll pass in sound number. And oh yeah, let me get rid of the constant declaration of sound name up here. I don't want that anymore, and I need to put a var in front of sound name because now this is where I'm declaring sound name. And actually, since I don't change sound name, I can make that a let constant. And now we should be ready to run. And hooray, everything works just fine. And you know what, as I'm watching the user interface, I'm wondering if our image might look nicer if it's centered in our app. So I'm gonna go up here and I'm gonna add a spacer in between our text view and our image view. And now let's try that out. I think that looks a little bit better. Now we do notice as we look at our code that we've got 3 chunks of code for generating non-repeating random values that look almost identical. So our next lesson will cover functions in Swift, and we'll create a function that we can use to generate random non-repeating numbers that'll allow us to cut down on the code that we've written, and we'll also write a function that separates sound play, so you'll have a chunk of code that you can easily paste into other apps where you want to use sound. But Swifter, I hope you feel sated because once again you were well fed by the Big Learning Buffet. We learned to play sounds in SwiftUI, import libraries, work with sound files, and we got a first taste of error handling with guardlet and do try catch. We even learned to watch out for those magic numbers and magic strings and how to deal with those guys with constants. Swifter, crank up the sound and celebrate your skills, but keep coming back 'cause there's more big learning to come.